Okay, let's get started with Unit 9. We're going to do Unit 9 a little bit backwards. We're going to do 9.1b first, just as a review of some stuff that we learned in 8th grade. So let's take a look at the I can statement. I can understand and find equations of parallel, and then the word we're going to write right here is perpendicular. So perpendicular lines. Now, hopefully you know what the two of those are. If you don't, we're going to review that just shortly here. A couple questions we have to start off with. What is the formula for slope if we have a graph? Well, if we have a graph, then we use two words. So those words are, we do the rise over the run. Remember, we always have to have the rise on top because that's the difference in the y's. So y rhymes with rise. So that's going to go on the top and the run goes on the bottom. And then you'll see next, if we've got 2 points, you'll see what we mean by that. We're going to find the difference in the y. So that's going to be y2 minus y1. Now, one thing I always advise is to write down the minus that's in that formula before you do anything else. So the bottom is going to be x2 minus x1. And then what is the slope-intercept form of linear equations? Well, we usually write them in slope-intercept form, and that is y equals mx plus b. So if somebody says slope-intercept, we're talking about y equals mx plus b. And if somebody says y equals mx plus b, then we're talking about slope-intercept form. Now, quick question here for you to think about. What is the x-coordinate of all y-intercepts? So we've got a whole bunch of lines that are going to cross the y-axis. Well, they might cross up here, down here, down here, down here, wherever it happens to be. Every single one of these, they have something in common. They have the exact same x-intercept. Y-intercept, or same x-coordinate, and that's going to be 0. This point right here is 0 comma something, big positive value. This is 0 comma something, that's 0, happens to be at the origin, so 0, 0. And this would be 0 and then some negative number over here, okay? Now, reminder, what is the equation of a horizontal line? Well, horizontal, like the horizon, is perfectly flat. And that's going to be y equals a number. And the reason that is if we come over here and we draw a horizontal line, it's going to cross through the x-axis at that point right there. So this is y equals a number. And then a vertical line is a line that's straight up and down. That's going to be x equals a number. And again, the reason for that is if we've got a vertical line, it comes down here and it hits the x-axis right at that place. So that's going to be x whatever that x-coordinate is. So remember, if we've got only one variable, it tells us which axis it crosses. So this crosses the y-axis, it's horizontal. This one crosses the x-axis, that makes it vertical. Now in this unit, we're going to study something called coordinate geometry. And that's just a fancy way of saying that we're going to study some geometry and some types of things that happen in geometry on the xy plane. So we all know what the xy plane is. We're going to start off with this right here. We want to remember, if we want to write the equation of a line, so like y equals mx plus b, they've got to give us some information. So here's what they've got to give us. They've got to give us at least one point, and they've got to give us the slope. So if they don't happen to give us the slope, they've got to give us enough information that we can find what the slope is. So we're going to take a look at this example 1. This is a reminder from 8th grade. You did some problems like this. So we want to find the equation of a line that goes through the point -4, 3 and 2, 5. And we want to write that in slope-intercept form. So the first thing that we're going to need is we're going to need the slope. So I'm going to write the little slope formula. And then just a reminder, the reason they use subscripts is this reminds us that this one is the first xy pair, and this one is the second xy pair. So that's the only reason. We've got an xy here and an xy there. This is the first xy pair, and that's the second xy pair. So we're going to do y2, which is 5, minus y1, which is 3. Make sure we get the y's on the top. And then x2 minus x1. So a lot of people will look at this and they'll say, oh, there's already a minus there, so I don't need to write it. You do need to write it because we're finding the difference between 2 and -4. So the top turns out to be just a 2. The bottom, this is a minus 4, so that's going to be a +4. So that's going to be a 6. We always want to work with reduced and simplified fractions. So we're going to make this the fraction 1/3. Okay, so what we've got so far is we know what the slope is. They didn't give us the slope, but they gave us enough information to figure out. So I'm going to write this down. Y equals mx plus b. We're going to write it in this format. And we know so far that we've got 1/3 for the slope, but what we don't know is we don't know what the y-intercept is. So we've got to find that. Now, if you take a look here, we've got three variables. We've got a y, an x, and a b. And if I take either one of these, it doesn't matter which one, I could plug in this xy pair or this xy pair into that equation. It should make it true. Well, since we can plug in either one we want, I kind of favor this one right here. The numbers are both positive and we tend to make fewer mistakes that way. So I'm going to take this and I'm going to plug it in right here. So I'm going to take the 5 and I'm going to plug it in right there. I'm going to take the 2 and I'm going to plug it in right there. So we're going to have 5 equals. This is 1/3 times x, and x happens to be 2. So plus b. So 5 equals 1/3 times 2. Oh, let's see, 1/3 times 2. Well, that's easy. Put that over a 1. Multiply the tops together, so that would be 2/3. So now all we have to do is we just need to get the b by itself. So I'm going to subtract 2/3 here and 2/3 here. Now, if you need to type that into a calculator, you're welcome to. This is going to end up being, if we write that in thirds, this is 15/3. And then we're going to subtract 2/3. So that's going to be 13/3. So 13/3 right here. So we got the slope from that formula right there. And then we got the y-intercept by plugging it into the slope-intercept form of the equation. So here it is. Y equals 1/3 x. We knew that for sure already. That was pretty quick. And then we figured out that the y-intercept was 13/3. So this is the answer. That's the equation. Now, just to double check, because we've got a graph over here, let's just check and see. This point was -4, 3, so that's right there. This point was 2, 5, so that's right there. And if we were to draw a line between the two of these, this is what it would look like. Now, I'm going to zoom in on that just a little bit so we can take a good look at it. Let's see. Our line had a y-intercept of, let's see, it was 1/3 x plus 13/3. Well, 13/3 is the same as, that would be 4 1/3. So if you take a look here, this crosses a little bit above 4, which is what we'd expect. And the slope of this is, we go through that point and that point and that point. We'll take a look. Rise 1, run 3. Rise 1, run 3. So that looks pretty darn good. We've got the right equation. We're in great shape. We know that this method works. If we've got 2 points, we can figure out the equation in slope-intercept form. So let's come down here and let's take a look at what we're really talking about today. That was just a reminder, very useful reminder. We're going to do some of this later. But we want to take a look at this. So we want to talk about parallel and perpendicular. So hopefully you remember what those words mean. Parallel means they're lines that they're parallel to each other. They never cross each other. They're like railroad tracks, some people will say. And the symbol for that is like this. And then perpendicular lines, they're special lines that meet at a right angle. They meet at a 90-degree angle. So hopefully you remember those symbols. That makes it a little shorter to write down those words. Now, it's easy to tell by looking if lines appear to be parallel or perpendicular, but we want to make sure. So if we want to make sure, we actually have to compute the slopes. So what we're going to do is we're going to look over here, and it kind of looks like this red one is perpendicular to both of these blue ones, and it looks like those two blue ones looks like they're parallel. But let's just double check and make sure. So we want to check the slopes of L and N. So line L, I'm going to go from here to here. And we usually go from left to right. I like doing the rise first and then the runs second. So this would be a rise 1 and a run of 3. So again, rise over run. The slope for line L would be 1 on the top, 3 on the bottom. Going to do the same thing here. We're going to go from that nice convenient point to this nice convenient point. So that's a rise of 1 and a run of 3. So the slope of that one is 1/3. Well, they look like they're parallel, and take a look at the slopes. Slope, remember, is a fraction that tells us how steep the line is and which direction it slants. These are both positive. They slope up from left to right, and they have the exact same steepness. So you notice that they're exactly the same. Okay, so that's what we notice about the slopes. Now let's calculate the slope for L. Well, we already did that one, and P. So P is this red one right here. So let's find 2 convenient points for that one. So I'm going to change this into blue. So I'm going to go from here down to there. So I'm going to rise down here, and then I'm going to run like that. I went down, so that's a rise of -3, and I run 1. Whoops, went to the right, so that's going to be a positive 1. So line L is still this line right here. It still has a slope of 1/3. If we find the slope of P, that's going to be a rise of -3 and a run of 1. So if we simplify that, you'll notice that we get a -3. So unlike where the slopes are the same and they're parallel, these two right here, they do have something in common though. In fact, if you look right here, it's pretty easy to see. they're fractions that are kind of flipped over. We call those reciprocals. Okay, so one of them is negative and they're opposites. Okay, so we've got a way to describe that, and we're going to write that down here. This is how we typically talk about parallel and perpendicular. Parallel lines have slopes that are exactly the same. So they're identical in every way. Same sign, same numbers, same fraction. And then if they're perpendicular, they have slopes that are, some fancy words here, that are opposite reciprocals. Okay. So when we say opposite reciprocals, what we mean is one of them is going to be negative and one of them is going to be positive. So they have opposite signs. And when we say reciprocals, we're taking the fractions and we're flipping them over. So this is positive. This one's negative. This is 1 over 3. This is 3 over 1. So they are indeed opposite reciprocals. Now, it's a really good idea not to forget that if we have a horizontal line, remember that's perfectly flat, and a vertical line straight up and down, those are perpendicular. So we'll use the little symbol there. And then if the lines aren't parallel and they're not perpendicular, then what we say is they're neither. There's really only 3 categories for this. They're either parallel, they're perpendicular. If I threw a line in like this, that would be neither. Okay. Now, if you're interested in how to prove that they have to be the same to be parallel or they have to be opposite reciprocals, Sal Khan on Khan Academy has a couple good videos where you can look that up. Okay, let's take a look at the backside and look at some examples from Alex. Okay, I think you'll like these problems. Most of them are pretty easy. So we've got to consider this line right here, and there's something really nice, hoping you notice that. And it says, what is the slope of a line that is perpendicular? So we want perpendicular first. And then it says, what's the slope of a line that is parallel? So we want parallel second. And if you've never seen this, notice that the word parallel has 2 L's that are right next to each other that are indeed parallel. They point off in the same direction. So that's one way you can remember how to spell parallel and also what parallel lines are. So the first thing we notice from this is it's in slope-intercept form. So that's in y equals mx plus b form. The only thing we need to determine whether lines are parallel or perpendicular is just the slope. So the slope on this one is -6. Well, the easiest one to do is actually the parallel one. The parallel one would have an exact same slope, so it's going to be -6. If it's going to be perpendicular, it's going to be the opposite reciprocal. So it's got to be the opposite sign. It's going to have to be positive. And we're going to take that fraction, or we can make it a fraction by putting it over 1, and we're going to flip it over, so we end up with 1/6. And it's literally that simple. Once you find the slope, you just take it and say, oh, if it's going to be parallel, it's going to be exactly the same, and we just need to be the opposite sign and the reciprocal of that fraction in order to be perpendicular. Now, they do pull a little trick on this one right here. If you take a look at this here, this will happen on some problems. Notice this isn't quite in slope-intercept form. What they've done is they've written this as y equals b plus mx. So they've written it in the wrong order. What we want to do is we want to make sure that we grab the right number. That number right there, the coefficient in front of the x, that's the slope. So it's -2/3. So again, let's come down to the parallel. That one's easiest. So it's just -2/3. And then perpendicular is going to be the opposite reciprocal. So opposite sign is going to be positive, and reciprocal is going to be 3/2. Okay. Now you'll see others, lots of different variations of those, but if they're written in slope-intercept form or really close, again, all you need to do is find the slope. So let's take a look at this problem right here, and you'll notice that there's something different. It's structured the same way. The instructions look exactly the same as the one above, but notice that this is in what we call standard form. It's actually not in slope-intercept form yet. So what we need to do is we need to get it in slope-intercept form. So to do that, we're going to subtract 8x from both sides. So we get 9y equals, this is going to be a -8x minus a 9. Whoops, forgot that 9 there. Then we're going to get the y all by itself by dividing everything by 9. Now, you'll notice that we get y equals, let's see, this is going to be -8/9 x. And then it really doesn't matter what this number turns out to be. We really don't care about the y-intercept. In this case, it happens to be -1. This is what we're really after. The slope of their line is -8/9. So what that means is ours has to be, if it's going to be parallel, -8/9. And then we have to have opposite reciprocals. So this one's going to be positive, and it's going to be 9/8. Okay, let's come down here and take a look at a few more. You've got a lot like that. I just want to point out, remember, don't forget that if there's a little picture over here, an icon of a person in front of a board or something, That's a teacher video that shows you exactly how to approach a problem like this. So this one says, find an equation and the slope of a line that is perpendicular to the y-axis. So perpendicular to the y-axis, and passes through the point 6, 7. Now, using paper to find this out, or using an Alex log, that would be really good. Okay, so here's what we're going to do. We're going to graph roughly where this would be. And if you look on an Alex log, there's actually kind of a grid work below that you can see just slightly. So that might be good. This point right here is 6, 7. Now, we want this to be perpendicular to the y-axis. Well, the y-axis is right here. So this is the y-axis and this is the x-axis. So we want it to be perpendicular to the y-axis. So that means we want it to go like this. We want it to be horizontal. Well, remember we said earlier that if it's horizontal, it's going to be y equals a number. And if it's vertical, it's going to be x equals a number. Okay, so this is going to be y equals a number. So we're going to have y equals a number here. And let's see, that number, let's see what it would be. Well, if this is at 6, 7, we went up 7, it's going to slide right over here. It's going to cut right across there at 7. So this is going to be y equals 7. Okay, now the slope of a line like that, remember, if it goes up from left to right, it's positive. If it's perfectly flat, it's 0. If it goes down from left to right, then it's negative. If it's straight up and down, then we say there's no slope, or sometimes we say that it's undefined. There isn't a number that represents that, okay? So this would have a slope of 0. Now, the good thing is you can just write y equals 7 on this one, and I think you can just write slope is 0. You don't have to write m or anything like that. If it happens to be undefined, we've got a button for you right there. Now, what if this problem did say parallel? I just want to cover that just in case. So if you run across one where it says parallel to one of the axes, in this case, the y-axis, if it's parallel to the y-axis runs up and down, it's vertical, so we'd have a line that looks like this. Well, if you think about it, remember, this was y equals a number because it was perfectly flat. That's going to be y equals 7. That's the answer we got to that one. Well, this one, this is going to be x equals a number. Well, the only x that it could possibly be is where it crosses the x-axis, this right here, which is that x coordinate for the point. It's going to be the 6 because we went over 6. So it's going to be x equals 6. And then the slope, what would we say for the slope? Well, straight up and down, remember, is undefined. So we'd grab that button right there and we would say undefined. Okay, just click that button and it'll take care of it for you. All right, let's take a look at the next one. This is the last one on the page. Again, reminder, most of these have videos where you can watch how to do this. This wants us to do a couple of things. It says, consider this line right here, y equals negative 4/7 x minus 6. And we want an equation that is parallel to that line that goes through 4, 3. And we want one that's perpendicular to that line. Okay, so perpendicular would look like this. Let me make parallel like that. Okay, and goes through 4, 3. So the thing we need from this is we really just need the slope. So the slope on this one is negative 4/7. So if we're going to do the parallel case first, so I'm going to do the parallel one first, then our slope would be exactly the same. If their slope is negative 4/7, our slope is negative 4/7. So we're going to have y equals, this would be negative 4/7 x plus b. So we know that it looks like this. We just need to find out what the y-intercept is. So we're going to take this y, we're going to put the 3 right there, and we're going to put the 4 right there. So let's go through and do this. This is going to be 3 equals negative 4/7 times 4 plus b. So we get 3 equals, that's negative 16/7 plus b. Again, if you need a calculator for any one of these things, you're totally welcome to grab one. We're going to add 16/7 to both sides. And again, that's totally a calculator problem if you want it to be. And then this would be, let's see, in sevenths, this would be 21/7. So we're going to add those together. If you check on your calculator, 3 plus 16/7 is going to be 37/7. So 37/7. So we've got the slope right here. We've got the y-intercept right here. So all we have to do is write down the equation. So if it was going to be parallel, it's going to be, in fact, I'll write it right here so we don't have to rewrite anything. Okay, we're going to transfer it over here and we're going to write y equals, this would be negative 4/7 x minus, positive, going to be positive here, positive 37/7. Okay, so there's the answer for that one. So now that we've got the parallel one, let's do the perpendicular one. If it's going to be perpendicular, so I'm just going to put perpendicular right here, the slope has to be the opposite sign. So this is going to be positive, and it's got to be the reciprocal. So that's going to be 7/4. Now, I think you're going to like what happens here. This is y equals 7/4 x plus b. And we're going to plug in this xy pair. So this is the x and this is the y. So the 3 is the y. We're going to put the 3 right here. We're going to have 7/4 times x. X is 4 plus b. Now, something kind of cool happens on this one, and I think it happens on every one of these, at least for one or the other. The 4's will cancel, so this is a 7 plus b. We're going to subtract the 7 from both sides, and we get -4 equals b. So now I've got the b, and I've got the slope. So what we end up with is y equals, this would be 7/4 x, and then this is going to be -4. And there's the answer. All right, good luck on the assignment.